Okay, 13.6. That will be part 2. Okay, about the chemical reactions of alkaline. Last video we talked about the chemical properties of alkaline. You have like 3A plus 1M. Okay, 3A that will be include can react with the acid, acidic gas, ammonium ion, the third A. Okay, 3A here. Okay, and last one is reacting with the metal ion. Remember, okay, it is reacting with the metal ion. It is not reacting with the metal. So comparing with the acid, okay, acid can react with the alkaline, that is base, which include metal oxide and metal hydroxide, and we have like carbonate and also metal. Okay, this one for acid, okay, they react with metal. They are not reacting with the metal ion. Okay, what means by that? Okay, just have a look at the example. For example, NaOH reacting with the Mg, NaOH, and then react with the MgSO4. So in this case, okay, the first equations, okay, reacting with the metal, okay, because you can see Mg atom only here. Or the second one, okay, reacting with the metal ion, okay, because the Mg in the compound, it exists as Mg2 plus, okay, so therefore, okay, according to the reactions, okay, alkaline react with the metal ion but not the metal. So the metal one, no reaction, and then the metal ion, you will have reaction. Okay, so same things happen, okay, to the metal, okay, or to the acid. So if you have like HCl react with the Mg, and also HCl react with the MgSO4. As the first one is metal, then you will have reaction to give salt and hydrogen. But for the second one, because this one is a metal ion, not metal, so in this case we have no reaction for this. Okay. So for this metal ion, okay, we'll talk about what kind of reaction it's going to have, okay, on a later manner. First of all, we'll just finish ammonium ion first. So for ammonium ion, okay, so the alkaline can react with ammonium ion, okay. Please pay attention to the word is IUM, ammonium ion. That will be NH4 plus, okay. They are not ammonia, okay. That is different, okay. So ammonium ion, okay, NH4 plus, we have reaction with the alkaline. So what we are doing, okay, we are putting the ammonium ion compound into NaOH. So we keep two liquid, okay, into a test tube like this, and then we will heat it, okay, we'll warm it, okay, with a Bunsen burner. So in the process, okay, they will form salts and ammonia. So some gas, okay, will be coming out, okay. So we do have ammonia going out, okay, like this, and it will also have water as well. Okay, so the ammonia coming out, okay, we'll use a paper to confirm, okay, that will be alkaline gas. So in the process, okay, this is a kind of test for ammonium ion. So we try to describe these experiments like this way. First of all, the test that we provide, okay, will be warm the solution with NaOH. Okay, we warm it first. If it contains ammonium ion, we will have a alkaline gas with characteristic pungent smell will be given out. Okay, so the characteristic pungent smell is about the ammonia. Ammonia, it smells like urine. Okay, but in DS you will say it's a characteristic pungent smell. If you say alkaline gas with urine, sorry, okay, I won't give you mark for that. Okay, so you have to remember the test, what kind of test we're doing, and what will be the observation. Alkaline gas, okay, just like normal gas, you cannot observe, okay, you cannot smell it, okay. So what we are doing, okay, we are use a moist red litmus paper to test it, because we know that alkaline, okay, can be tested by red litmus paper, okay, but this one is gas form, like previously in the acid. We know that, okay, if it is in solid state, okay, it have no water, there will be no reaction. So for this alkaline gas, we have to provide a moist one for that first, okay. Moist, that means it have water in it. So sometimes people, they may say, okay, that will be a wet red litmus paper. That will be all right, okay. So as long as it is wet, okay, that will be all right. The alkaline gas, when it touch the water there, they will dissolve and then form an alkaline. This alkaline will then react with the red paper, okay, and then turn it into blue. Okay, so for this one, okay, the test for ammonia is very important, and the test for ammonia gas NH3 is also important. Okay, like what we have mentioned just now. Okay, it will test. We're using a moist red litmus paper. This keyword, okay, the moist, okay, is very important. Okay, moist red litmus paper to test the gas. If it is ammonia, the red litmus paper will turn blue. Okay, so these two these sections, okay, these two tests, okay, is very important, and also the equation as well. So you'll find that the equation is a little bit difficult, but actually it's not that difficult. So you imagine the NH4 plus like NH3 plus and H plus. If you consider it like that way, every one NH4 plus give one NH3 and one H plus. That would be easy for you to balance, okay? Because you can see that, okay, in this case you have one NH4 plus, so you should have one NH3. Okay, one NH3. And then you got H plus right there. If you have H plus here, you got OH minus. So these two will combine to form water. Leaving behind, okay, you just have Cl and Na, they will combine to form the salts, okay? So just as I mentioned, this H plus and OH minus, they will form the water. So actually, it is not that difficult to balance this one, okay? If you do an ionic equation, okay, you can see that the Cl minus and Na plus, okay, will be eliminated in the process. So leaving behind, you have NH4 plus, OH minus to give ammonia gas and water, okay? So that will be the reaction with the ammonium ion. I highly recommend you to go through this QR code, okay, the YouTube videos, and that it will show you the experiments, okay, for like testing the ammonium ion, okay, like this one, okay. Okay, so let's have a look of a exercise. Okay, class practice 14.6. So we have 4 compounds. So we have a KOH here, an MgO, zinc hydroxide, and also you have copper 2 oxide. So which of the above substance is alkaline? Remember, alkaline is soluble base. Okay, so soluble base, okay, you just have KOH right here. For the rest, they should be insoluble. Okay, so they will be solid. Okay, so the first one, write ionic equation. Okay, for the reaction, okay, of KOH with dilute hydrochloric acid. If you remember, okay, KOH, HCl. Okay, they will give KCl and also H2O. Because the KOH is alkaline, so it can be broken down into K plus and OH minus. So basically, KCl, okay, will be eliminated. So the answer for this one should be OH minus, H plus, and also water. Okay, so second one, write about substance insoluble base, just as we mentioned. Okay, for the rest will be insoluble base, and then you have to write an ionic equation with dilute hydrochloric acid. Remember, all the acid in ionic equation actually it will be exist as H plus. So this one is no different at all. Okay, so this one, okay, we'll just write quick one. So for CuO, okay, right here, okay, I'll just write a quick one, okay, I'm not going to cross bit by bit, okay, with you. So we have H plus right there. Okay, remember you have O, okay, you need 2 H plus to combine with water, to form water. So this one will be Cu2 plus and H2O. Second one, okay, will be MgO. So I think this one is more or less the same, okay, you need H2H plus, okay, to form the water right there, okay. And then the last one will be zinc hydroxide, okay, zinc hydroxide, and then H plus. As each of the OH minus need 1 H plus, so you have 2 OH minus here. So again, you have 2 H plus, okay. So for this one, okay, you should have zinc 2 plus, and also have 2 H2O, okay. So you have 2 H2O right there. And for the second one, 2A. Write a chemical equation and ionic equation for each of the following reaction. So the first one, it will be KOH react with the CO2. So this one will be an alkaline react with acidic gas. Alkaline acidic gas, it should be given out salt and water. So the salts that we will have will be K2CO3. How do you know that? Okay, so actually CO2 you dissolve in water, you give carbonic acid. So I can see K and CO3 right there. Okay, so next, okay, that will be water. Okay, you got salt and water, right? So here, okay, the ratios, we check the ratios. So you see that K is 2, C is 1. So K, this one I need 2, this one I need 1. So to balance this one, you have 2 KOH and then CO2. Okay, so if you check closely, actually the equation will be balanced in this way. Okay, because the gas, okay, we have is the carbon dioxide is in gas state, so it cannot be broken down into ions, okay, for this, okay, but for the K right there, okay, this K plus and this K plus can be eliminated. So for ionic equation, basically you have like OH minus and then CO2, and you got CO3 2 minus and also H2O. So that one would be part A, 2A, okay. Part B, okay, that would be ammonium ion, okay, ammonium ion. So ammonium chloride together with calcium hydroxide. So the salts that we'll have is calcium chloride. Remember the ratio is 1 to 2 because calcium is 2 plus. So therefore this NH4Cl, it should have 2 NH4Cl right there. So 2 NH4, so you should have 2 NH3. And also you have 2 OH, so you should have 2 H2O. So the equation balance is just like this, okay? Ionic equation, chloride ion, eliminate. Calcium ion, eliminate. So therefore, leaving behind, you should have 2 NH4 plus and 2 OH minus. And then giving out, you have 2 NH3 and 2 H2O. Oh, you see, everyone have 2. So actually, these 2 can be eliminated one more time and rewrite it by yourselves. Okay, so that's all for this exercise. Okay, so have a look of the summary.